Hello again guys, Mad King Corduroy here, and I'm finally getting to do something I've been wanting to do since 2008. Back in 2008, I got my PCjr, which is my first foray into retro computing. Along with that system, I got a bunch of other stuff, boxes of software, and this VHS tape. On this VHS tape is a copy of Arthur Young's Learning Lotus 123, which is a self-teaching course that came out in 1984 and retailed for around $320. You could send away from this in many magazines. The ads were basically everywhere around that time, and in fact, I have a review that came with it, and I'm going to be scanning this and including a link if you guys want to go ahead and read that. And I will also try and get a hold of the original workbook and stuff like that and create copies for you guys to look at. Hopefully I will not get slapped with copyright infringement because it's such old material. I'm hoping I can get away with that. But if you do see this and you own copyright to this, please don't slap me with that. I'm just trying to preserve this historical information for other retro computer users. Just tell me and I'll take it down or make it private or something if you have a problem with it. So yeah, let's go ahead and watch the video, take it out, and pop it in the machine.
Competitor.
Welcome to another in Arthur Young's series of video-based training programs. I'm Dave Wilson, Director of Education Services at Arthur Young. I'd like to take some time to explain a little bit about this program. Arthur Young and our affiliates in Arthur Young International are public accounting firms. Like you, we are faced with the need to integrate microcomputer technology into our daily operations. As our own needs and those of our clients and business associates have grown, so too has our range of educational products and services. One of our goals has been to assist people in getting their feet wet with computers in a way that's comfortable for them. In 1983 alone, more than 6,000 executives, managers, and professionals participated in Arthur Young International microcomputer training programs. If this is your first exposure to microcomputers, even if it's not, I hope that you will find, as others have found, that this training program is not only useful, but enjoyable as well. In a moment, I'll turn you over to two of my colleagues, Andrew Innes, a computer audit partner, and Don Bowman, a microcomputer training specialist. Before I do so, let me say thank you for joining us, and good luck.
Dawn and I are pleased to be with you through this training program. I'll be doing the talking and explaining, and Dawn will be demonstrating the procedures. Before we jump into the more technical modules, let me take a moment to set the stage. Since you've gone as far as taking this course, chances are you already know that the Lotus 123 program is an integrated electronic spreadsheet, graphics, and data management package, and that it is a registered trademark of Lotus Development Corporation. What you perhaps don't know is that it's very easy to use and very powerful. We fully expect that by the end of this course, you'll be quite comfortable with the 123 software. You'll be able to build your own worksheets, or models as they're sometimes called, produce graphic representations, and create and manage lists of data without difficulty. If this is your first microcomputer experience, you may be just a little bit frightened. Don't be. Short of physical abuse, it is difficult to break a microcomputer. And secondly, you don't have to be a programmer to instruct the machine. Software like the 123 software makes it very easy for you to obtain useful output quickly. We've designed this course to be self-instructional. The training program is broken into several modules. Each module will include a video segment, a chapter in your participant's workbook, and usually, but not always, a hands-on exercise. It really is imperative that you read the instructions for these exercises carefully and do not race ahead. Before we get started, let's quickly review the structure of your participant's workbook. If you turn now to Chapter 4, entitled the 1, 2, 3 worksheet, you'll be able to follow along with me. Each section of the course workbook has a maximum of 4 parts. An introduction, covering the objectives and instructions on how to proceed through each section. Here you'll get an idea of the knowledge and skills you can expect to acquire in each module. Section highlights, providing a summary of the main points covered in each section. Section highlights serve as a refresher during the course and act as a handy reference in your first few weeks of working with the software. Exercises, listing step-by-step instructions to work through on your microcomputer. It is these in particular that you must follow faithfully. These exercises are your opportunity to put into practice what you've learned. Additional notes, clarifying some of the points raised or providing new material. Check here first if you're unsure of anything. Near the end of the workbook, there is a reference section. This provides detailed instructions on how to use each of the 1, 2, 3 commands, and should be useful to you as a permanent reference when using the 1, 2, 3 software. Lastly, at the end of the workbook, there are answers to some selected problems. Now, turn to your participant's workbook and read the introduction. Dawn and I will be with you through the course, so good luck. For many people, knowing something about the components of a microcomputer can make learning everything else that much easier. So why don't we do just that? Why don't we take a look at the components? All micros have 4 basic parts: a keyboard, a display unit, a central processing unit, and auxiliary storage units. Along with these, a printer is very common and very useful. As I talk about each of these components, I'll also take some time to introduce you to a few of the microcomputers the 1, 2, 3 program will operate on. Let's start with the keyboard. The keyboard is used to communicate with your program. It is very similar to a standard typewriter keyboard, but with a few additional keys. We can identify 3 different kinds of keys on this Texas Instruments professional computer keyboard. We have what are called function keys across the top. These are special purpose keys. In this area are the keys that resemble a standard typewriter. And on the right are the arrow keys that are used for moving around the display unit or screen. And finally, at the far right, a numeric keypad to help make typing in numbers much easier. Keys on all these machines are very similar. Where differences exist, they have to do with the key's physical placement on the keyboard or the name used for a key. For example, on the Hyperion, the arrow keys are combined with the numeric keypad, while on this IBM PC, the function keys are on the left, not on the top. An example of the different naming conventions is the backspace key. It's labeled backspace on the Texas Instruments, rub out on the Hyperion, and just an arrow pointing left on the IBM. Even though it does have 3 different identities, it does exactly the same thing on all 3 microcomputers when it's pressed. Now, let's take a look at the display unit. This is also called a monitor or screen, and this is what the program uses to communicate with you. It is also what you use to see what the program is doing for you. The monitor is like your home TV set in that you can adjust contrast and brightness. Monitors can be different sizes and shapes. This Texas Instruments monitor is about the size of a 13-inch television. And the Hyperion over there has a monitor which is much smaller, but built in with the other components. Monitors can also display in different colors. The IBM monitor over here displays in green, which is probably the most common color. The Hyperion, on the other hand, displays in amber, while this Texas Instruments has a color monitor which displays many different colors. The next component I'd like to talk about is called the Central Processing Unit, or CPU. It's this rectangular box that houses the microcomputer's brains. The circuit boards and silicon chips typical of microcomputer technology are contained within this unit. Simply stated, circuits exist to control the basic operations of the microcomputer or how it physically performs the instructions we give it. Also in this unit is what is called main memory. This is where programs, data, or calculation results are temporarily stored while waiting to be processed. You've probably heard the expression 64K machine. This refers to the size of main memory and means that the machine can store approximately 64,000 characters of data in its CPU. Data which can be accessed very, very quickly, but unfortunately is lost when the machine is turned off. The memory capacity will vary from one microcomputer to the next, and even between different models of the same microcomputer. To be able to store data more permanently, we have an auxiliary storage unit, disk drives in our case. Disk drives are used to read information from or to write information to diskettes. The microcomputers we will use have two disk drives. They may be either side by side, as on this Texas Instruments, or one on top of the other, as in the case of the Hyperion. The drive on the left, or on the top, is called drive A, and the drive on the right, or the bottom, is called drive B. Diskettes are small round disks like these, similar to any 45 RPM record. They store magnetically encoded data in a manner similar to magnetic tape. Each diskette is contained in a sealed plastic envelope like this. This envelope is made to be heavy-duty and is lubricated and static resistant. Needless to say, the diskette should never be removed from the sealed envelope, or it will be ruined. Diskettes require careful treatment, or several hours of work can disappear because of one fingerprint or speck of dust. Some of the do's and don'ts in caring for your diskettes are: don't bend them. Don't keep them in a very warm place. Don't expose them to electric or magnetic fields, so don't leave them on top of the monitor. Don't put them on chairs or carpets, even temporarily, as they will pick up lint, dust, and static. Don't touch the exposed plastic surfaces when handling the diskettes. Don't use them upside down. And always store the diskettes in the special jackets provided by the manufacturer. This is made to be static resistant. Ideally, for longer periods, diskettes should be stored vertically in the box provided by the manufacturer like this. But failing this, they should be at least stored flat and with no weight on them. When inserted into the disk drive, the diskette is spun rapidly, allowing the read-write head of the disk drive to access any part of the diskette as it passes through this slot here in the envelope. Before we start working with the 123 program, or any other program for that matter, we must put the operating system into the memory from a diskette. This procedure is called booting or loading. We'll show you how to do this in the next chapter. If while using your microcomputer you would like a hard copy or printed copy of your work, you'll need a printer. There are many varieties of printers available. The one that we have happens to be an Anidex printer. Whatever the printer that you have, some features are fairly common. To state perhaps the obvious, it must be turned on. Also, it must be online or hooked up to receive the print signals from the CPU. This particular model is referred to as a wide carriage printer. It can use the familiar wide green striped computer paper that you may receive from your EDP department. Some models, however, are what we call narrow carriage and can only use paper that is 8.5 inches wide. For instructions on how to use your particular model, you may need to consult your printer manual. In this chapter, we've introduced you to the components of a microcomputer and shown you a few of the different types of microcomputers on which the 123 program will operate. Let's look at the components one more time. The keyboard, the monitor, the CPU, the disk drives and diskettes, and the printer. In the next chapter, you'll actually begin to work with your microcomputer when we show you how to load the 123 program into memory. In this session, we'll show you how to transfer or load the 123 program from diskette into your microcomputer's memory. We'll also show you how to prepare blank diskettes for storing your data. We'll be using a number of different diskettes to do this, so let's begin by identifying these. When you purchased your microcomputer, you also acquired an operating system, or DOS, with a manual like this and a diskette. This diskette contains a set of programs which are used in the overall control and management of your microcomputer. This information is kept on diskette rather than built right into the computer because occasionally DOS versions have to be updated. And frankly, it's more efficient to simply issue a new diskette than to go around replacing silicon chips in every microcomputer. Your Lotus 123 software package consists of a user manual like this, a function key template like this, and 5 diskettes. We will primarily be using the diskettes labeled 123 system diskette and 123 utility diskette. We'll talk more about these in a moment. When we turn on the power, our microcomputer automatically looks in drive A. It's looking for a diskette that contains specific information, part of the disk operating system or DOS. Once the computer finds the required information, it goes on to read whatever programs are contained on the diskette. This process is known as booting, and diskettes containing the required information are called self-starting. The 123 diskettes do not include the DOS information our computer needs when they are first purchased. Instead, room has been left on the program diskettes for us to install this information ourselves. We do this by copying it from our own version of the DOS diskette to our 123 program diskettes. If, as a first-time user, you're getting a little nervous about all these technical aspects, relax. It may be that you're not the first person to use your package, and the boot information has already been installed. If this is the case, feel free to skip ahead to the Preparing a Data Diskette section of this video. But before you do, you may want to turn back to the workbook and review some of the concepts that we'll be covering when we make our 123 diskettes self-starting. On the other hand, if your 123 diskettes have not been made self-starting, we'll show you how to do this now, step by step. We begin by using the DOS diskette that came with our IBM PC. Dawn inserts this diskette into drive A. She does this gently raising the drive door and holding the diskette by the label like this, and turning it so that the slot in the cover is pointing toward the drive with the label facing up. She pushes the diskette in squarely as far as it will go, but without forcing it. She flips down the door and the diskette is now ready to be accessed. The power switch is on the right near the back. Turning the machine on, in a few seconds, you'll hear some whirring and clicking noises, and the light on drive A will come on. This means that information is being read from the diskette into main memory. While the red light is on, don't open the door or try to remove the diskette, because the data stored on it could be damaged. When the drive stops turning and the red light goes off, we see a message which tells us what date the machine thinks it is, and we are asked to enter a new date. A little flashing bar called a cursor is the signal for us to begin typing. Dawn types today's date in exactly the same format as the date on the screen. Numbers only with the month first, separating each part with a hyphen. She then presses the Enter or Return key to tell the computer that she's finished typing. The system will then repeat a similar message asking for the time. She types in the time again in the required format and finishes by pressing Return. Now an A appears followed by a bracket. This is called a prompt and represents disk drive A. Next, we're ready to load the 123 system diskette. So, we remove the tab folded over the side of the diskette just beside the label. This is called a Write Protect tab. It actually covers a little notch cut out of the diskette envelope. If the notch has been covered by a tab, the computer will not be able to write onto the diskette. As you can imagine, this is a very useful precaution against accidentally erasing our diskette, particularly an expensive program diskette like the 123 program. After we've removed the Write Protect tab, we place the system diskette in drive B and close the door. Then we type B:install, remembering to hold the Shift key down while typing the colon. And we're sure not to insert any spaces in the command. Then we press Return. Now a message appears asking us to be sure the DOS diskette is in drive A and the 123 system diskette is in drive B. When all is set, we press any key to continue. When the process is complete, the A prompt reappears with the flashing cursor next to it. When the drive lights go off, we remove the diskette from drive B, replace the Write Protect tab, and place the diskette in its protective jacket. We repeat the B:install process with all the 123 system diskettes, the system diskette backup, print graph, and utility diskettes. We're always sure to remove the Write Protect tab for each diskette before placing them in drive B. When we've completed the install process for each diskette, the A prompt should be back on the screen. We remove the DOS diskette from drive A and return it to its protective jacket. It's done its job now. It's provided the 123 diskettes with the necessary control programs to make them self-starting. We have one more thing to do, however, before we can start using the 123 programs. As I mentioned earlier in the last session, there are various types of monitors available to use with our microcomputer. Because of this, we have to let the 123 program know which kind we're using. To help us do this, the 123 utility diskette provides us with several small satellite programs to choose from. These are called drivers. We're using a monitor with a green display, often referred to as a monochrome monitor. Let's see how we tell this to the 123 programs. First, we place the 123 utility diskette in drive A. We'll refer to this as the source drive. Drive B we'll call the target drive. We type MONO for monochrome, space, B, colon, and press Return. A series of messages will now appear on the screen to confirm that drive A is the source drive and drive B the target drive. When all is set, we will press any key to continue. Now we are prompted, after all that, to insert the 123 system diskette in drive B, the target drive. So once again, we remove the Write Protect tab. And strike any key to continue. When the process is complete for the system diskette, we will be prompted for each of the other 123 diskettes. When you do this, be sure to follow through the prompts on the screen, and as you finish with each diskette, replace the right Protect tab. Also, remember to return the diskette to its protective jacket. Why don't you take some time now to turn to your workbook and review what we've covered so far. If your 123 diskettes need to be prepared, take some time to do that too. Welcome back. Now that your 123 diskettes are self-starting, we can use them. After we loaded the 123 program, we'll want to start putting in our own data. But what happens at the end of the day? How will we be able to save our data? Certainly not on our program diskettes, because they're already jam-packed with information. For our own data, we'll need to prepare some data diskettes. The first thing we need to do is to again load our 123 system diskette into memory, or boot it. Remember how we did this with the DOS diskette? We started with our microcomputer turned off. Okay, now we insert the 123 system diskette in drive A, close the drive door, and turn the power back on. After the usual whirring and clicking noises, we are asked to enter the current date as before. Here it is. And press return. Again for the current time. As before, we type it in the required format and press return. After a few moments, the Lotus Access System menu appears. The menu choices are on the second line, and a description of these is highlighted under that. The 123 program is the Lotus spreadsheet, graphics, and database program. And this is what our ultimate goal is. But remember, before we can get to this, we need to prepare some data diskettes first. So unfortunately, we can't choose this choice yet. The Choice Disk Manager contains a utility that allows us to prepare a diskette. So, with the right arrow key, we move the pointer to highlight Disk Manager and press the return key to accept this choice. Now we are instructed to select a disk management program and are given the options of disk copy, compare, prepare, or status. We would like to prepare our blank diskette so that it can store our data. So we move the pointer to prepare option with the right arrow key, and again, press return. Next, we are asked to confirm that this is indeed what we would like to do. We are also reminded that prepare will destroy any data on the diskette in drive B. We select yes to proceed with the disk prepare command. Now, we are instructed to insert the utility disk in drive A and to press enter. So we open the drive door, remove the 123 system diskette, and in its place, we put the utility disk into drive A. We close the door and press enter. At the top of the screen, we are instructed to insert a new diskette in drive B and to strike any key when ready. We place the blank diskette in drive B, close the drive door, and press any key. The red light on drive B goes on and the whirring and clicking resumes. After a minute or so, some diskette statistics appear. We're now asked if we would like to format yet another diskette. At this point, we can do so by pressing Y, or we can quit by pressing N. For now, we'll just format one blank diskette, so we type N. And after a few seconds, we're back at the Lotus Access System menu. Well, we're finally ready to call up the 123 spreadsheet program and begin learning how to use it. The 123 choice, as you can see, is already highlighted, so all we have to do is press return. Next, we are instructed to insert the Lotus system diskette in drive A and to press enter. So we remove the utility diskette, insert the system diskette in its place, close the drive door, and press enter. After some whirring and clicking, the Lotus 123 copyright information will appear. We press any key to erase this, and there we have it, our 123 program worksheet. We've covered a lot in this session: the disk operating system and why it's important to your microcomputer, preparing the 123 diskettes to be self-starting, booting the 123 system diskette, preparing, or formatting as we called it, blank diskettes to be used for storing data. And finally, we got to our 123 worksheet. Take some time now to go back to your workbook to review some of these concepts and to follow through the procedures to prepare your data diskettes. When you return, we'll introduce you to the world of the 123 worksheet. With the screen as your paper and the keyboard as your pencil, we'll now show you how to use the worksheet. Welcome to the Paperless Society. During this session, you'll be given practical hands-on experience. But first, let's take a look at the worksheet. In the last session, I showed you how to load the 123 program into memory. When we did this, a 123 worksheet appeared on the screen, ready to be written on using any of the 123 commands. On the screen, you now see a blank 123 worksheet. There are really two areas of this worksheet. The first three lines are called the control panel. We'll look at this in more detail later on. Below the control panel is the actual worksheet, where we enter data. Let's first look at the borders of our worksheet. There you see 8 column headings, A to H, and 20 rows, 1 to 20. In fact, there are many more positions on the worksheet than are visible on the screen. In fact, the maximum size of the worksheet is 256 columns by 2,048 rows. You could look at it this way. At any one time, the screen displays only a portion of the entire worksheet. You are looking through a movable window that can be moved or scrolled to look at any portion of the worksheet. The worksheet is like a huge grid, and the intersection point of each row and column is called a cell. Each cell may be referred to by specifying its coordinates, column first, and then row number. For example, C4 specifies the cell at the intersection of column C and row 4. The highlighted bar you see on the screen is called the cell pointer. To enter data into a certain cell, this pointer must be placed at that location. The pointer is moved around the screen by pressing the arrow keys. There are 4 arrow keys, and they move the pointer up, down, and to the left and right. Notice something. By holding down the arrow keys, they repeat automatically. If you try to move the pointer past the edge of the worksheet, the computer beeps at you. Generally, it beeps any time it's trying to get your attention. Possibly you may have done something unusual, and it is warning you. While the arrow keys are one way to move the pointer, a second and much quicker way is to use one of the special function keys we mentioned earlier. In this case, we can use the F5 key, which activates the go-to command. By pressing the F5 key, a question appears which asks us to enter the cell location that we would like to move the pointer to. Notice, though, that the 123 program has already provided an answer. In fact, the program will often do this. It will assume that the response to its question is the current pointer location. For example, our cell pointer is currently at location A6. When we hit the F5 key, the program assumes that that's the cell we want to go to, A6. In our case, since the assumption isn't correct, we can change it by typing in the correct answer. In fact, we want to go to cell C10, so we type this and press the return key. In a flash, the pointer moves to C10. Now let's look more closely at how we enter data into a cell. There are two types of entries you can create, labels and values. But how does the 123 program tell which type of entry you are creating? That is determined by the character we start the entry with. For instance, if we start an entry with a number, or even certain arithmetic characters, such as the plus or minus sign, the program assumes that we are entering a value. If, on the other hand, we start the entry with a letter, the program assumes that the entry will be a label. Let's test 123's educated guess system and enter data into a cell. First, the cell pointer must be moved to the location where we would like to enter our data. We have placed the pointer at cell C3. Let's say we would like to enter the number 23. We type a 2 on the keyboard, and notice that the word value appears in the upper right corner. This is the program's way of announcing its guess about which type of entry we are creating. We proceed by typing a 3, and then press the Enter key to tell the program that we have completed our entry. The data is now entered onto the worksheet. Let's try again. This time, let's enter the number 1234 in cell B3. First, we press the right arrow key to move the pointer one position to the right. Always remember to position the pointer where you would like the data to appear. Otherwise, you'll end up with data in the wrong position. Again, we simply type in the number 1234. Notice, though, that it still isn't on the worksheet, and that's because we haven't yet pressed the Enter key. Press Enter, and presto, our value is now on the worksheet. So far, I've talked only about entering numeric data. However, in drawing up your worksheet, you'll almost certainly want to enter labels or headings to improve its appearance. Let's see how we do this. To illustrate this, let's label the entries made in row 3 sales. First, we move the pointer to cell B3 and start entering our label sales. We type an S, and once again the program states which type of entry this will be by the word label appearing in the upper right corner. We complete our entry with A, L, E, S, and then press the Enter key. The word sales now appears on the worksheet. When we entered data, we saw that the 123 program tells us which type of entry we're creating. And this is one of the nice things about the program. It helps us use it. The upper part of the screen contains information that we can read if we are unsure about what is taking place. These 3 lines are called the control panel. Let's now take a look at each of these 3 lines. The first line of the control panel shows us the pointer location and what's in the cell. The control panel displays the pointer location B3 and the label sales, which is the cell content. As we move the pointer with arrow keys, the control panel information changes. In the far right corner is an indicator, which tells us which mode the 123 program is in. We saw how this worked when we entered data. The program told us which type of entry we were creating by changing the indicator to value or label. The second line displays several things. If you're entering data, it shows you the characters of your entries as you type them. It also displays the 123 commands. We'll show you how to activate the commands later in this session. And finally, this line displays prompts which ask us for additional information. Remember the prompt when we used the Go-To key? It asked us to enter the cell location we'd like to go to. The third line of the control panel displays quick summaries of the 123 commands, which, as we said, we'll discuss later. For now, why don't you practice some of the things we've covered so far? So, turn to the workbook and follow the instructions for the first exercise. Now it's your turn to practice entering data. Don't worry about any typing errors you make. When you return, we'll discuss different ways to fix your terrible typos. Welcome back. If your typing is like mine, chances are you probably made some typing mistakes while you were doing the workbook exercise. We're now going to show you different ways to correct those typing errors. Let's first cover how to correct errors as we're entering the data. In cell B3, we'll enter the number 1234. Uh-oh, we typed a 6 instead of a 4. Fortunately, we can correct this by using the backspace key. When we press the backspace key, the pointer moves backwards, erasing the 6 as it goes. We can then enter a 4 as we had originally planned. Press the Enter key, and our corrected entry appears on the worksheet. A more drastic way to make corrections as we enter data is to cancel the entire entry. And this is done by using the Escape key. Let's move the pointer to cell C3 and type in the label totals. However, as we're entering it, we really make a mess of it. Instead of trying to correct it, we can cancel it and start typing all over again. By pressing the Escape key, it cancels the entire entry. Everything we had before pressing the Escape key is gone. We can now start typing the word totals again, and then, of course, press the Enter key. Before we continue, let me remind you that the backspace and Escape keys work for these examples because we corrected the mistakes before we pressed the Enter key. There will be times, on the other hand, when you realize a typing mistake only after you've entered the data onto the worksheet. Or maybe what you've entered in the worksheet is not really what you wanted to do at all. How do we correct these? Let's take a look. By far the easiest way is to simply retype the cell. With our pointer on cell C3, let's replace the word totals with the number 5,000. When we press the Enter key, our new number appears in that cell. But what if we don't want to retype the contents of a cell? We may not wish to type the entry again just to make a single correction. Let's say we want to change the contents of cell C3 from 5,000 to 6,000. This can be done easily by using the F2 key, which puts us into the edit mode. When we press the F2 key, the mode indicator in the upper right corner changes to edit, and the contents of cell C3 are displayed on the second line of the control panel. We can now make our change. First, let's delete the number 5. We'll move the edit pointer to the 5 by pressing the left arrow key 4 times. Now press the delete key to delete this character. To insert the 6, we simply type in the number 6, and it will replace the 5 that we deleted and move the remaining zeros to the right. To tell the program we're done with the change, we press Enter. Why don't you take some time now and practice these correction techniques? When you return, we'll continue our discussion on data correction. The correction techniques you just practiced help to change the contents of a cell entry. But what if you wanted to erase the entry completely? Well, one command you could use is the range erase. How do we do this? First, we activate the command menu. To do this, we press the / key, and the commands appear on the second line of the control panel. The names of the commands should give you an idea of the sort of things each command can do: move, print, graph, and so on. If you forget, you can always glance at the third line of the control panel, which will explain the option or indicate additional menu choices within the option. We'll look at these in detail as we go through the rest of the course. The command that we'll use is the range command. To select this command, we use the right arrow key to move the menu pointer to the range command. Notice how the additional options of the range command appear on line 3 of the control panel. When we press the return key, these additional options move to the second line and are now available for selection. The one that we need is erase. So let's move the menu pointer to erase, and notice the explanation on the third line, that this option will erase a cell or range of cells. We press Enter to select this option. Now the 123 program prompts us to enter a range to erase. Well, we all know what the word erase means, but what does the word range mean? Well, in fact, a range is a rectangular piece of the worksheet. On the screen, we see the simplest type of a range, that is, only one cell. By using the arrow keys, we can enlarge this range. Now our range is 4 columns wide, and by using the arrow keys again, we can extend this range so that it's 4 columns wide and 4 rows deep. The rectangle can be many different shapes. Let's take a look at some of these now. All of these are ranges to the 1, 2, 3 program. Visually, we've seen what a range looks like. Now let's show you how the program indicates a range. If we look at the second line of the control panel, we'll see a cell reference of C13 followed by 2 periods, and then another cell reference of F17. The 2 cell references C13 and F17 are the 2 corners of our range. Notice something. When we press the arrow keys to change our range, the second cell reference changes. However, the first cell reference remains the same. It is as if it's anchored. In fact, it is. The 1, 2, 3 program tells us that cell C13 is anchored by 2 periods after the cell reference. If we decide that this location is not where we want to anchor it, we can change it by pressing the escape key. Notice that our 2 periods have been removed. With the arrow keys, we can move the range corner anywhere on the screen, then anchor it again by pressing the period key. When we do, 2 periods and a second corner reference reappear. At this time, we can use the arrow keys and proceed as before to extend our range. When we have the range we would like, we press the Enter key to tell the 1, 2, 3 program that we're done. Once again, in summary, a range is a group of 1 or more cells that form a rectangle. You'll see throughout this course that there are many times when you can specify a range of cells for the 1, 2, 3 program to process as a unit. Now let's apply what we've learned about ranges and erase some cell entries. As you can see on the screen, we have some data to work with. Let's erase the label totals located in cell B11. We'll place the pointer at this cell. We now press / for the command menu, point to range, and press Enter. Finally, we press E for erase. Notice that we were able to select the erase option by merely typing the first letter of the option name, E. Now we are prompted to enter a range to erase. The program is trying to help us again by giving us the pointer location as the range. Since this is in fact the range that we would like, we accept it by pressing Return. And the contents of cell B11 are gone. Let's now erase the label Chicago and its sales figures for the year. Press / to activate the command menu, R for range, and then E for erase. Once again, the 1, 2, 3 program gives us a range to erase. In this case, we would like to extend that range from B9 to F9. So to do this, we press the right arrow key until our pointer is extended to cell F9. With the press of the return key, the cells are erased. Thus far, we have discussed several correction methods. We've gone from the simple technique of retyping the correction to erasing a range of cells. A more drastic correction method would be to erase the entire worksheet. This is considered drastic because all data entered on the worksheet is now gone. This technique is sometimes used when you start working on a new application or model. Let's clear our current worksheet. Press / W for worksheet. Uh-oh, we've mistakenly hit Q for quit instead of W for worksheet, and we are now in the quit command. There may be times when you select the wrong command and would like to return to the previous menu. Remember the escape key? It allows us to cancel the current operation. By pressing it, we exit this menu and return to the previous menu, in this case, our main command line. Now we can select the command we really wanted. We press W for worksheet, and again we are given several options to choose from. The one that we would like is erase, so we press E. Now, just in case we've made a mistake, the program double checks. It asks us to confirm our intentions. We can either cancel the command at this point by selecting no, or continue by selecting yes. We respond by typing Y for yes. Our worksheet is cleared, and we get a new, fresh one. While the worksheet command is a fairly drastic means of correcting typing errors, we can take it one step further with the quit command. This command allows us to end the 123 session and return back to the Lotus access system. Press / and Q for quit. Once again, the system asks us to confirm our choice. We respond by typing Y. Our worksheet is gone, and we are returned to the Lotus access system. Well, there's only one more thing you'll need to know in order to complete your next workbook session, and that is how to retrieve data from a file that already exists on a diskette. Let's see how this is done. First, we need to return to the 123 program. Press the Enter key to select that option. Here it is, the copyright information. Now we can press a key to continue, and our worksheet reappears. Now we can press a / to activate the command menu. The command we'll be looking at now is the file command. This command is the 123 program's way of allowing us to access the disk drives. After positioning the menu pointer on the file command, we press Enter. Again, we see the options available to us. At this point, we wish to select the Retrieve command to retrieve a file from our diskette. The menu pointer is already on this command, so we simply press the Return key. A prompt now appears asking us to enter the name of the file we wish to retrieve. At this time, we could type in the file name. However, on the line below, the program lists the file names that we currently have on our diskette. Simply by using the arrow keys, we can move the pointer to highlight the file of our choice. This is easier than typing the file name and prevents us from making a typing error. Let's load the file named Sales. With the pointer located on this file, we press the Return key. And there we have the file loaded into the computer and ready for us to start working on. In this module, we've introduced you to the 123 electronic worksheet. We've covered pointer movement, data entry, data correction techniques, and finally, the file retrieve command. In the next module, we'll look at one of the features which makes the 123 program so powerful, its ability to use the data entered to perform calculations. Now we'd like to show you how to do arithmetic using the 123 program. In this module, you'll begin to discover the magic of electronic spreadsheets and why the eraser will soon be a thing of the past. When we do arithmetic, we use the same operations you're already familiar with, like addition and subtraction. Let's take a look at how the 123 program recognizes these operations we'll be using. Addition, as you may have guessed, is indicated by a plus sign, subtraction by a minus, multiplication by an asterisk, division by a slash, and exponentiation by a caret. Arithmetic formulas are created by combining numbers or cells with the operators we've just mentioned. For example, 1 plus 2 simply adds 1 and 2, but C2 plus C3 adds the values of cell C2 and C3 together. C2 asterisk C3, on the other hand, means the value in cell C2 times the value in C3. Now let's show you these in action. We'll add these columns of numbers. One way to perform the calculation would be to enter the formula 1 plus 5 plus 9. Press Return to tell the 123 program that we're done. The result of the formula 15 is displayed in the cell where we entered the formula. Another way of achieving the same result would be by adding the cells together instead of the numbers. For instance, 1 is in C3, 5 is in C4, and 9 is in C5. So we type C3 plus C4 plus C5. Now, before we press return, let's take a look. Strangely, something doesn't seem quite right. Our cell references are okay, but the mode indicator tells us that we're entering a label. And clearly this isn't what we want. Now this has happened because as soon as we entered the first C, the 123 program assumed we were entering a label. In fact, we must force the 123 program to think we are entering a value, and we do this by starting out with a math symbol, like a plus sign. Let's cancel this entry with the escape key and start over again, this time with a plus, C3 plus C4 plus C5. Everything looks good now. Our mode indicator says value, and we can press enter. We get the same result by entering either the numbers or the cell references. What was one of the potential problems we had with our last formula? I can think of one. We were typing it. But why don't we use the program's friendliness to reduce the chance of our typos? Instead of typing in cell references, we could let the 123 program type them in as we point to them. Let's demonstrate. Since we would like a formula, we'll start out with a plus sign. Then, instead of typing D3, we'll point to the 1. Notice that as we move the pointer to the 1, the cell in the formula changes. Once the pointer is positioned, typing the next plus sign records that cell in the formula. Now we can point to the next number, the 5. Type plus, and then point to the 9. Strike the return key to tell the 123 program that that's the end of the formula, and the answer appears. Once again, we get the same result even though we used a different method of creating the formula. The formula even looks just as it did when we typed in each cell. But the chances of making an error by pointing are greatly reduced, especially for a not-so-accomplished typist like myself, one who hunts and pecks his way around the keyboard. Now it's your turn to practice creating formulas. Turn back to your workbook and work through the first Chapter 5 exercise. Now you've created some of your own formulas, you can see that this instant calculation ability based on stored formulas is an extremely useful tool. With formulas like these, we can set up an entire financial model. In fact, let's go through a small example. Let's set up an income statement model. Our income statement is only going to have 3 lines: sales, cost of sales, and gross profit. Cost of sales will be a percentage of sales, and gross profit will be the difference between sales and cost of sales. Sometimes it's hard to keep track of all these relationships in our heads. If we set up the labels first, we'll have an outline of our model that lets us visualize where the formulas will go. Well, we know we're going to need a label for sales, cost of sales, and gross profit. Let's start with these and enter sales at A9. Move the pointer to A9 and type sales, and return. Let's abbreviate cost of sales to COS and have it at A10. Move the pointer down 1 row, type COS, and return. Finally, move to A11 and type gross profit and return. Why don't we have our model on a monthly basis? Let's put January in column B of row 8, February in column C, March in column D, and so on, through December in column M. Now we have our outline that helps us enter our income statement formulas. Notice, though, that as it is now, the description gross profit is too long for its cell. The last three letters spill over into column B, where our January gross profit is to be located. To fix this, we could either abbreviate gross profit, or we could change the width of column A. The 123 program has a special command that will allow us to adjust individual column widths. Let's move to gross profit and make column A a little bit wider. First, we type a slash to get us into the command mode. Column width is an option of the worksheet command, so we press W for worksheet and C for column width. Our final choice is S to set the width of the current column. To set the column width, we can use the arrow keys. By using the left and right arrow keys, we can make the column width as big or as small as we would like. In this case, we would like to make it large enough so the gross profit is contained within a single cell. Now press return, and our new column width is set. Now we're finally ready to begin building the formulas for our income statement. We'll start by setting January sales, located at B9, to 1,000. Move the pointer to B9, type 1,000, and press return for the 123 program to accept the value. We would like January cost of sales at B10 to be 60% of sales. Our formula then will be January sales times 60%. Move the pointer to B10 and type plus to start the formula. Point to January sales, press asterisk for multiply, type 60%. Then press return to tell the 123 program that we're done. The answer 600 appears at B10, and the formula is displayed in the first line of the control panel. Notice that our formula is a little bit different from that which we typed in. The 123 program converted 60% to 0.6. The formula we would like to enter for gross profit is sales minus cost of sales. So we move to B11, type plus to start the formula, point to sales, type minus, point to cost of sales, and strike return. The answer 400 appears at B11, and we have the beginnings of our income statement. Now that we have the first month set up, let's experiment with it a little bit. Suppose we want to change the value of sales to 2,000. Move the pointer to B9, enter 2,000, and press return. Look what's happened. Immediately the values of cost of sales and gross profit change, because they are both based on sales, and we didn't even have to use an eraser. This is an example of the recalculation feature of spreadsheet programs. One of the real benefits of an electronic spreadsheet like the 123 program is being able to make a change very easily and to see the effect very quickly. Let's make another change. Now we would like the cost of sales factor to be 70% instead of 60. To do this, we need to change the formula. So let's edit it. We move the pointer to the cell we would like to change, B10 in this case, and press the F2 key. We would like to change the 0.6 to 0.7. Move the 6 with the arrow key, press delete, and type in 7. Finally, return records the change. Why don't you take a few minutes now to turn back to the workbook and do the next exercise on creating formulas and making changes to them. Let's face it, changing the value in cost of sales with the edit feature wasn't much fun, was it? When you changed a single value, such as sales, it was much easier than changing a formula. What if we could set up our model so that all changes were that easy to make? We can, as a matter of fact, using what we call a data entry area. Under this concept, assumptions are extracted from the body of the model and listed separately in the data entry area. Assumptions are those values which will change over and over again to see their effect on our model. Assumptions we've used so far have been sales and the factor for cost of sales. Let's pull these out and put them in a data entry area at the top of our worksheet. To do this, we move the pointer to A4 and type starting sales. Press return, then move down one row to A5 and type cost factor. And press return again. We'll put the values for all these assumptions in column C. So we move to C4 and type 2000. Return, and at C5, type 70%. And finish with return. Now we need to change the formulas in the body of our income statement model. Let's retype. The January sales will be the sales figure we have in the data entry area. We move the pointer to January sales, type plus to begin the formula, and point to the starting sales at C4. Now return to end this particular formula. Move to cost of sales, plus, point to January sales, times, and now point to the cost of sales factor at C5. End the formula by striking return. All we need to do now to make changes to our income statement model is to change the figures in the data entry area. Let's try. Move to starting sales and change it back to 1000. Our January figures are quickly recalculated. Enter 60% for our cost factor. Quickly changes the cost of sales and gross profit amounts in the income statement. The data entry area makes changing data so much quicker and leaves less chance of making an error. Let's expand our model to the next month. First, we move the pointer to C9. We'll have February sales increase over the previous month's sales, January's, by some factor. Our formula will be January sales times, let's say, 110%, or, in other terms, plus B9 asterisk 110%. But wait, remember we don't want numbers that might change in the body of our income statement model. So let's set up another line in our data entry area for a growth factor. We move up to cell A6, type growth factor, press return, and at C6 we will set our growth factor to 110%. Now we can set up our February sales formula. Moving back down to C9, we begin the formula with a plus. Point to January sales, asterisk for multiply, point to the growth factor at C6, and return. Terrific. Cost of sales will be just as before, so we move to C10, type plus, point to February sales, asterisk for times, point to the cost factor, and return. The formula for gross profit will also be the same as before, sales minus cost of sales. So we move to gross profit and start with the plus sign. Point to February sales, minus, point to February cost of sales, and return. Whew. You know, even now, we've got a fair amount of time invested in this model, and it would be a shame if somehow it were accidentally erased, or someone tripped over the plug. All of the work we've done so far is only in the computer's main memory. For as I mentioned earlier, when the computer is turned off, anything in main memory is lost. Therefore, we need a way to put the information in main memory onto a diskette. As it happens, the 123 program provides us with this capability. First, we must get into the command mode by typing a slash. If we move the pointer to the file command, we can see that one of the options we have is save. Of course, this is what we would like to do, so we press the return key to accept the file command, and then S for save. To save our worksheet, we must give it its own unique name. We usually try to pick a name that is descriptive. In this case, what about income for our worksheet? We type income and press return. Notice the red light on drive B comes on and we hear whirring noises. This means a copy of our income statement model is being recorded on the diskette in drive B. When the light goes out, the save process is complete, and we can be assured of not losing our work. Let's review what we've covered in this chapter. We learned various methods of creating a formula, and found out that pointing out the formula is in fact the easiest way of creating one. We learned how to change column widths. We discovered that recalculation is a powerful feature of the 1-2-3 program. We also saw how data entry can be restricted to a data entry area so that our model is easier to work with. And we learned how to save our model onto a diskette. Take some time now to go to the workbook and practice some of the spreadsheet functions that we've covered to date. The copy command is probably the most powerful feature of the 1-2-3 program. By using the copy command, we can duplicate labels, values, and even formulas. When we use copy, we'll be able to copy a cell to a cell to a range, or a range to a range. Think of it for a moment. Instead of spending your time keying labels and formulas for many months, you can spend your time, instead, getting exactly what you want in one cell, and then simply copying that cell for as many other cells as you desire. Now that's what I call a good use of time. We're going to approach the copy command this way. First, we'll learn how to copy labels and values, and then we'll use it for formulas. Essentially, we're going to learn how to walk before we can run. We really only have to know the answers to two questions to use the copy command. From and to. That is, from which locations and to which locations would we wish to copy something. If we pay attention to the control panel, the 1-2-3 program will prompt us to answer these two questions. Let's take a look. We've already put the word month in cell C3, so we have something to copy. Before we start, let's move the pointer to C3. It's always a good idea to start the copy command with the pointer on the cell that we would like to copy. We'll explain why in a moment. We select the copy command just like any other command by pressing /. Then move the menu pointer to copy and press enter. Before we start pressing keys, let's take a look at what's going on. The 1-2-3 program is giving us a lot of clues as to what we should be doing next. Line 2 of the control panel has the words enter range 2, copy from, then some cell references. This is the first question of the copy command, the from part. Note also that cell C3 is highlighted and that the range C3 through C3 is indicated as the answer to the from question. All of this happened just by originally selecting copy as our choice of commands. Remember when I mentioned that it was a good idea to start the copy command with the pointer on the cell that you wanted to copy? Perhaps now you see why. The 1-2-3 program assumes that what you want to copy starts with the pointer location. Actually, in this case, all we want to copy is cell C3. We don't really need to tell the 1-2-3 program any more about question 1, the from part. To indicate we're done answering this particular question, we press enter. When we've done that, the second question, or the to part, appears on the screen. Once again, the 1-2-3 program is giving us clues as to what it wants. The mode indicator is telling us to point out the range that we want to copy to. Let's say we wanted our copy to be placed in cell F3. Since the 1-2-3 program is expecting us to point to something, let's move the pointer to F3. Notice the cell reference that's part of question 2 changes as we move. Now we press period to anchor our range. Let's stop for a moment with our pointer on cell F3. We don't really want to expand our range, since F3 is the only place we want to put our copy. All we have to do now, therefore, is to press return, and our copy will appear. Let's try it. There you are. The contents of cell C3 have been copied to F3, and the pointer has jumped back to the cell where we started the copy command. Let's try it again, this time without as much discussion by me. Instead of copying to cell F3, let's put the copy into F5. Before we start, we make sure the pointer is on the cell we want to copy. And it is. So we press /C for copy. Now, because we had our pointer at C3 when we started, the 123 program has assumed that that's what we want to copy. And it's right. So we press enter. Now we need to answer question 2, where to put the copy. Let's point to F5. First to column F, then down to F5, anchor it, and press enter. Voila, an instant copy. You know, when we copied the word month to cell F5, we didn't have to stop there. We could just as easily have created a whole row or column of words. Let's see how we do that. Let's move the pointer to C10 and try it with the value 1, 2, 3, 4, 5. Okay, we've got the pointer at the cell we want to copy, so we can invoke the copy command. Press / and then C for copy, and once again the 123 program has made the right assumption. It has inserted the range C10 through C10 as the answer to question 1, the from question. All we have to do, therefore, is to press enter. And here's the second question, the to question. Now, let's say we want to copy the value 1, 2, 3, 4, 5 into columns E, F, G, and H. We simply move the pointer with the arrow key to column E, anchor the beginning of the range by pressing the period, and move to column H. This is exactly like expanding a range with any other 1, 2, 3 command. For example, remember the range erase? This is the same concept. Now, are we finished telling the 123 program all the information it needs? Well, as a matter of fact, yes. We told it that C10 was the range we wanted to copy from, and that E10 through H10 was the range to copy to. So let's press enter. Again, the copy is executed exactly as we desired. Are you anxious to try it yourself? Let me show you one more feature before you do. Here we have one row that we've copied to several rows. Let me erase this and show you how it's done. First, move the pointer to D13, since that's the upper left part of the range we want to copy. Press /C to activate the copy command. Look what 123 has assumed. It's partially correct. We did want our copy to start at D13, but not to stop with just that cell. Instead of pressing enter to indicate acceptance, we point to the end of the range by moving the pointer with the arrow keys over to cell H13. Now we're ready to press enter. Okay, the second question. The 123 program is ready to put our row wherever we point. And if we point there and anchor it, the 123 program will copy one row there. Now, if we expand it to another row, the 123 program will copy 2 rows. In this case, let's make it 5 rows. Press return, and we have it. Now, why don't you try it? Turn to your workbook and follow the instructions for the first of Chapter 6's exercises. Welcome back. While you've been mastering the basics of copying, we've loaded our income statement model. Just to refresh your memory, let's quickly review what our model does. Cell B10, the cell where the pointer is, has a formula which evaluates as current period sales times the cost factor in the data entry area. In the terms of the 123 program, that would be plus B9 times C5. Cell B11 has a formula which evaluates as current period sales minus current period costs, or plus B9 minus B10. We also had formulas for February, but we erased them to give us practice rebuilding formulas. Remember what it was, however. It was prior period sales times the growth factor. Let's build that formula by pointing with the pointer. Plus, don't forget to start with that. Now, the arrow key to point to prior period sales, times, use the arrow key up to the growth factor in our data entry area, press return, and we've got it. Let's do it one more time for March. Over to March, so we can start. The formula is here going to be February sales times growth, or plus C9 asterisk C6. Let's point with the pointer. Plus, to get us started, over to February with the pointer, times, now up to growth, and return. Good. I think we've got the concept. Instead of doing this for the rest of the months, let's see if copy can help us out. Since we know the concept of how the formula should work, let's predict what the formula for April would be if we keyed it in ourselves. Well, it would be March sales times the growth factor, or plus D9 asterisk C6. Since we're going to need to refer back to that formula later on, let me use the magic of video to record it on our screen. Now for the copy. Press /C, then press Enter to accept the 123 program's assumption that it's okay to copy the range D9. Now to answer the second question. Point to April sales, anchor it, and press Enter. There, we have it. Uh-oh. We've obviously made a mistake. Let's take a look at the formula the copy just created for April sales. We know what we wanted it to be, plus D9 asterisk C6. The plus D9 reference is right, but what's happened to our C6? Instead of C6, it has been changed to D6. The answer is this. When the 123 program copies a formula, it makes an assumption. And that assumption is as follows. Unless you tell the 123 program otherwise, when it copies from one column to the next, it increases all cell references by a column. Now, fortunately, we can control the assumptions the 123 program makes. In our situation, we were happy with the program when it changed our column reference for sales from plus C9 to plus D9. But we didn't want C6 to change to D6 at the same time. That's because no matter which month we're talking about, the growth factor is always going to be at cell C6. When this situation occurs, the cell is referred to as absolute. So how do we let the 123 program know a cell reference in a formula should be absolute? It has to be done when the formula is being constructed. Actually, the formulas for February and March are correct, but they don't indicate whether the cell references are absolute or not. Let's redo them. Moving to February sales, press /range, E for erase, point to March and April sales, and then press Enter. Okay, starting with February sales, our formula is going to be January sales times the growth factor. This time, however, when we indicate the growth factor, we will also tell the program that that cell reference is absolute. Plus, left arrow to January sales, times, up to growth, but before pressing Enter, we press the F4 key first. Notice that the cell reference C6 now has two dollar signs embedded in it. This is the 123 program's indication that a cell reference is absolute. Now press Return. Let's see if copy works now. Our pointer is already on the formula we want to copy, so we press /C and enter to accept the range. Now point to March, press period to anchor the range, and press enter to indicate we're done. Good. Copy is working as planned. If we look at the formula that was copied, we see that our cell reference of B9 has indeed been changed to C9, but our growth factor of C6 remains the same. Let's check our remaining formulas to see if they need to have absolute references also. The formula at B10 evaluates as current period sales times the cost factor, or plus B9 asterisk C5. If we were to copy this formula to February, we would want B9 changed to C9 because that's where current period sales are for February. That one's right. The cost factor, however, even when we're in February's column, will still be in cell C5. In other words, the cost factor's location never changes, no matter which month we're referencing. It is absolute. Let's use the edit command to fix up the C5 reference. All we need to do is to insert some dollar signs and we'll be ready. So we press F2 to edit. Move the edit cursor to the C, then press the dollar sign. Move it to the 5 and press the dollar sign again. There. That looks good now. Press enter to accept our edited formula. Now to try copy. As a matter of fact, let's get a little adventurous and copy January's cost of sales into February and March. We press /C, then enter to indicate January is what we want to copy, point to February, then press period to anchor our range, point to March, and press enter. Fantastic, it works. One last formula, gross profit. The formula evaluates as current period sales minus current period costs, or plus B9 minus B10. The question is, when we copy this formula to February, should B9 become C9, and should B10 become C10? Because that's what the 123 program will do, unless we tell it that some cells are absolute. Of course, the answer is that we want the 123 program to change the cells. When we move to February, we want our gross profit to be based on February's sales and costs, not January's. So the 123 program's changes are going to be all right. We don't need to indicate that any of these cells are absolute. We're ready to go. Press /C and return to accept the range B11. We want our range to appear in February and March. First point to February, press period to anchor the range, now point to March and press enter. Terrific, working exactly as predicted. Are you ready for the finale? Let's copy all of March and put it into April through December. First, we move the pointer to March sales, press /C, and point to the entire column. Press enter to indicate you're done with question 1. For the second question, the to part of copy, first point to April, anchor the range by pressing period, then point to December, press enter, and we're finished. Before you try it on your own, let me give you a rule of thumb that can help you decide if a cell reference is absolute or not. If you construct a model such as this with a data entry area, formula references to the data entry area are always absolute. When we want to access a variable in that area, it will always be to that specific location. Formula references to locations down in the body of the model, however, as in our income statement, for example, are generally not absolute. Okay, armed with that rule of thumb, retrieve your income statement from diskette and follow the instructions in your workbook. When you've finished, we'll come back and discuss an easy way to get totals into the last column of our income statement. we've learned how to create and copy formulas, it's time to look at some formulas that are already built into the 1, 2, 3 program for your use. These ready-made built-in formulas are called functions, and they provide us with shortcuts in performing certain calculations. One of the most useful of these functions is the sum function. Suppose that we would like to add the values in all the cells from B2 through B5, placing the total in cell B7. We could, of course, enter the formula plus B2, plus B3, plus B4, and so on. But this is tedious even to say, never mind type. Instead, let's try using the sum function. As usual, we put the pointer where we want our answer to appear. Then, to let the program know we're about to use one of its functions, we type an @ sign. All functions begin with this sign. Next, we type the name of the function we would like to use, sum. Now we need to indicate the range of cells we would like to add. The program will expect the range to be inside brackets, so first we enter a left bracket. Then point to the first value to be included, type a period to keep that address as the beginning of the range, and as we press the down arrow key, our pointer expands until we've included cell B5, the last value in our range. Is that everything? As a matter of fact, it is. So, we can now close our brackets, and when we press return, you guessed it, there's our answer. What if we would like to add more than one row or column of numbers? Can we specify more than one range within a single function? Well, let's try it. We'll add all the values in these two columns from B2 to B5 and from C2 to C5, placing the answer at C7. We're going to use a function, so we start with the @ sign and the function's name, followed by a left bracket. And now to set up our ranges. We start by pointing to B2 and type a period to anchor the range. Then we move down to point to B5. We've set up one range, but now we want another. So we tell the program to continue by typing a comma. The second range starts at C2, so again we type a period. And finally, we complete the range by pointing to C5 and closing our brackets. As soon as we press return, the program adds the values in our ranges and puts the answer on the worksheet. Well, that works very well. But are there other shortcuts available to us? Let's take a look at another, the average function. As you might guess, the average function calculates the average of a range of values. Let's calculate the average for cells B2 through B5. This time we'll put the answer in B8. We start with an @ sign because we're going to use a function. And we can use a short form of the name average, AVG. The range has to be enclosed by brackets, remember? So we must type a left bracket, point to our range, close the brackets, and finish with return. The 1, 2, 3 program takes care of the rest. There may also be times when you'll need to know the number of items within a range of cells. The program is ready. Just use what is called the count function. It works the same way as the sum and average functions, and we'll try it out here very quickly. We'll count how many values are in these two columns. Okay, we type an @ sign, the function name count, a left bracket, point out our first range, type a comma to separate it from our second range, which we can now point out. Close with the right bracket and press return. Aha! Altogether we have 8 values in our 2 ranges. It's now your turn to try it. Follow the instructions in your workbook, and when you're ready, we'll incorporate some functions into our income statement model. Hello again. While you were working on that exercise, we were loading our income statement model. And it's time to work out our totals in this model for the year, using the sum function. Here we are at cell N9, where we want our total sales to appear. To start, we type the @ sign, the function name sum, then a left bracket. We would like to add all the sales from January to December. So we point to January's figure, type a period, point to December's figure, close the bracket, and press return. There it is. Let's do the same for cost of sales. The @ sign and function name sum, open bracket, point out the range, close the brackets, and press return. Now, to complete our income statement, we'll need to calculate gross profit for the year. This time, I'll be quiet while you watch the action. There it is. In this session, we've looked at the sum, average, and count functions. In fact, these are just 3 of over 40 functions offered by the 123 program. Anticipating the needs of a wide variety of users, the program has built-in formulas for mathematical, trigonometric, logical, financial, statistical functions, and many more. In a later session, we'll look at some more of these functions, but don't worry, we won't expect you to be an expert in all of them by the end of the course. You have enough on your hands just learning the basics. And it's more important that you understand the concept of how to use these functions and know that they are available. To give you some more practice in using the functions, in your next workbook exercise, you'll complete the year-end totals in your income statement. And in the next session, we'll find out how to improve the readability of your worksheet. So far, we've developed a fully functioning income statement model using the powerful commands and functions of 123. We can change a variable in the data entry area and in an instant see the results throughout our worksheet. Technically, our worksheet is working perfectly. However, there are some cosmetic changes that would improve its appearance. How about this? We used some of the 123 program's rearranging and formatting features to make our income statement model here easier to read. In this session, we'll look at ways to enhance the worksheet layout by inserting and deleting rows, moving a range, and changing some formats. Let's see what we did to rearrange this income statement. To do this, we need to start with our model as we left it in the last session. So we call it back again by typing / F for file, R for retrieve, and we now choose income and press return. Here it is. Before we start rearranging anything, let's preserve our current formula for February sales over here on this side so we can see how it's affected. Okay. Now the first thing we did was to put a blank row between the month and the sales data. To do this, we used the insert option of the worksheet command. We begin this command with a pointer on the sales row, because the new row will be inserted at the pointer location and everything else moved down. So we type a / to bring up the command menu. Notice the cursor is now highlighting worksheet, and below that is listed the options available with the worksheet command. One of these is insert, which is what we would like. So we accept worksheet by pressing return and type I for insert. Now we have two choices. Do we wish to insert a column or a row? In this case, we'd like to insert a row, so we type R. We are prompted to enter an insert range. In other words, to tell the program where we would like this new row inserted. The 123 program assumes that we would like the new blank row put at the pointer location, and as it happens, that's correct. So we press return to accept the range, and the new row appears, and the other rows are moved down. Now the question is, how did inserting this blank row affect our formulas? If you remember, February sales should be prior period sales times the growth factor. Before inserting the row, we had plus B9 asterisk, $C, $6. Dollar signs, if you recall, mean that the C is an absolute value. Now we have plus B10 asterisk, $C, $6. So the 123 program has automatically adjusted the cell references to reflect their new locations. In fact, the program will always adjust cell references when rows or columns are moved around. Now, let's insert another blank row, this time between cost of sales and gross profit. First, we place the pointer on the gross profit row. Remember that we would like the new row to appear here, and for gross profit to be moved down one row. Type a slash, W for worksheet, then I for insert. Again, we have a choice of inserting a column or a row. We type R for row. Again, the 123 program prompts us to enter the insert range. The default response, once again, is correct. We want the blank row inserted where we've positioned our pointer, so we simply press return to accept it. The 123 program inserts a blank row between cost of sales and gross profit, just as we wanted, and automatically adjusts our formulas. The worksheet delete command works the same way as the insert command. To try it out, let's delete a couple of blank rows above our data entry area. First, we put our pointer on row 2. This is the first row we'd like to delete. And then we type a slash, W for worksheet, and the letter D for delete. Again, we're given the choice of deleting either a column or a row. We type R to select row, and now it's time to indicate which row or rows are to be removed. You'll notice the program is suggesting C2 through C2 because that's where we put our pointer. But in fact, we would like to delete rows 2 and 3, so we move the pointer down one row. Now 2 rows are highlighted and will be deleted, which is fine. So we press return and our worksheet is adjusted accordingly. One thing to keep in mind is that the delete command will happily remove any area you indicate in your instruction, whether it's blank or full of data. Unfortunately, data deleted in this way is irrecoverable, unless you have previously saved your model to diskette. We have saved our income statement in this format so that we can show you what would happen if we accidentally deleted, say, the row containing the sales figures for the year. Uh-oh, error messages throughout. You see, the program will do whatever you tell it to do, whether it's really a good idea or not. The point is, watch where you put your pointer and keep a close eye on the control panel when setting out your ranges. One additional comment about the insert and delete commands before you try it on your own. Inserting and deleting columns works exactly the same way as rows. As we saw, blank rows were inserted or deleted at our pointer location. Columns are also inserted and deleted at the pointer's location. With that in mind, turn to the workbook and practice inserting and deleting both rows and columns. Welcome back. In the workbook exercise, you had a chance to insert and delete rows and columns and to see the effect of these on the references in formulas. Let's take a look now at one more rearranging command and see how we could use it to improve the looks of our income statement. If you remember, in the improved income statement that we saw at the very beginning of this session, we had moved the data entry area over one column to the right. We did this using the move command. In fact, the move command is very similar to the copy command in that we will be prompted to answer two questions, where to move from and where to move to. Also, like copy, it's a good idea to begin with your cursor in the upper left corner of the range that you intend to move. Let's try it. Move the cursor to A2, type / to call up the command line, choose the move command by typing M, and here's the first question, the from part. Point out the range by moving the cell pointer to C4. Okay, that's all we want to move, so we press return to get the second question, the where to move to. Since we would like our data entry area off the borders, let's have it begin at B2. We move the cell pointer to B2, anchor the corner, and press return. Once again, our cell references are automatically adjusted. If we move back to February sales, we can see that the reference to growth factor has indeed changed to cell D4. Well, now that we've rearranged our model somewhat, let's see how we aligned the months and rounded the dollars. You can see that our month's headings are not aligned over the columns of figures. And, in fact, this makes our worksheet look rather difficult to read. To change the alignment of our headings, we can use the label prefix option of the range command. First, we move the pointer to January, type a /, R for range, and L to select the label prefix option. Now we have a choice. Do we wish to align the labels to the left side, the right side, or center them in the cell? If we align them to the right, they'll appear directly over our columns of figures, a real improvement. So let's do that. Let's press R for right. Now the program wants us to set out a range, and once again it's suggesting our cell pointer's location, B6. We could accept this, but instead let's extend the range to include all of our month's headings. We press the right arrow until our range has expanded to include the total heading at N6. Good, that looks all right. So let's press return, and in a flash, all our headings are aligned with our columns of figures. Now, we really don't need 3 decimal places in our values, which is a little bit confusing. So instead, let's round to whole dollars and set off the thousands position with a comma. This procedure we call formatting cells, and when we format cells, the contents of the cell is not actually changed in memory. Only the way it appears on the screen is changed. We can accomplish both our goals, rounding to whole dollars and inserting commas, by using the format option of the range command. As usual, let's place our pointer in the upper left corner of the range we would like to format, cell B8. Now we'll type a / R for range, and our cursor is already highlighting the format option, so just press return. Now we have, in fact, several options to choose from. We could format the cells to contain a fixed number of decimal positions, or we could format them in scientific notation. In fact, there are many different ways to adjust the appearance of our data. We would like the cells to contain commas, so we move the menu pointer to the comma. In this format, commas will be inserted in all numbers in the thousands, and all negative values will be enclosed in brackets. This sounds like a good start, so let's press return to accept the option. First, we're asked to specify the number of decimal places we need. It suggests 2 decimal places, but we would like to round our values to whole dollars, so we type instead the number 0 and press return. Next, we're prompted for the range of cells to format. We'd like all of our values formatted, so let's expand the range. First, we move the pointer over to the total column, and then down to include cost of sales and gross profit. Finally, we finish by pressing return. There we have it. All our values have been rounded to whole dollars, and commas have been inserted to show thousands. One last thing to complete our worksheet. Let's insert lines to separate the totals. We put a single line above gross profit and a double line under it. First, the single line. We put the cell pointer at cell B10 And to draw a single line, we'll use the hyphen character. We press the space bar 3 times, and then the hyphen 6 times. And then press return. That looks good. We could repeat this for each cell, but there's an easier way. Remember the copy command? We'll type a slash, then C for copy. Now, remember, we have 2 questions to answer, from where and to where. First, the from question. The 123 program assumes that we would like to copy cell B10, because that's where our pointer is located. In this instance, that's okay, so we press return. Now to the to question. We move the pointer over to the right 1 cell, type a period to anchor our range, and move the pointer over to the total column. When we press return, our line is copied across the worksheet. Let's now do the same thing for the double total line, starting with our pointer at B12. We press the space bar 3 times, press the equal sign 6 times for a double underscore, and then press return. Now we just need to copy it right across the worksheet as before. There we have it. Our income statement model is now much easier to read. In this session, we have covered several commands to rearrange or enhance our data, making the worksheet easier to read. The techniques we used included the insert and delete options of the worksheet command, the move command, and finally the label prefix and format options of the range command. Why don't you take some time now to finish your own income statement by following the instructions in your workbook. When you're through, we'll show you how to print out a copy of a completed income statement. Now that we've formatted and rearranged our worksheet so it's easy to read, let's move on to show you how to get a printed copy of your model. Sometimes reviewing a model on the screen is difficult because you can only see a portion of it at any one time. And after all, a printout or hard copy, as it's sometimes called, is often what you really need as an end product. We'll be using an Anidex printer to get our hard copy. The Anidex is a dot matrix printer similar to many printers available in the microcomputer environment. Dot matrix simply means that the characters are formed by tiny dots as opposed to the individual letter forms of a typewriter. Typewriter quality printers, usually called letter quality, are in general much slower, although they do produce a higher quality of resolution. This particular printer can print 132 characters per line. This is the size of most reports that you have received from your EDP department. It's also convenient for most microcomputer applications because, as you'll see, it is wide enough to hold our entire income statement model on one page. As with all peripherals, simply a fancy word that means something plugged into the computer, we've got to make sure that the printer is ready to receive data from the computer. In our case, that means lining up the paper, turning on the power, and making sure that the printer is online, ready to communicate with the computer. We're ready at this end, so let's see how we get the other end, the microcomputer, to cooperate. We've already got our income statement model in memory. We could print any specific portion of this schedule, but let's get a copy of the entire year, including the totals. To get started, we type a slash to call up the commands, and then the letter P for print, and here we have the first of several print command menus. We have the choice of sending our information to the printer or putting it in a file on diskette. Now, we might want to put it on a file on diskette if, at some later time, we wanted to incorporate a picture of this model in another software package for, say, word processing. In our case, we'll press return to select the printer option, since we want our report to be printed right now. And we're faced with the next print command submenu. Actually, this menu is the home base of the print command. All print features start from here. We'll even start the printer from here by telling it to go. First, however, what options are available to us? Range, which is highlighted by the cursor at this moment, allows us to specify the area of the model to be printed. Line and page advance the printer a line and page respectively. This brings up an interesting feature of the 123 program. 123 likes to be in control of things, and it doesn't like to let go. Frequently, after printing a report, you will turn the printer knob to advance the paper so that you can tear the paper off. And when you do this, however, the 123 program doesn't recognize that you've done it. It still thinks that the printer is sitting in the middle of the page where it left off. Consequently, when you next go to print, you can get some very strange results. Generally speaking, if you want to advance the paper in the printer, you use the line or page options from this menu. On the other hand, if you forget to do this and everything seems out of whack, all is not lost. Remember, you are in control. Simply line up the printer paper again and choose a line from this menu. That tells the 123 program to forget whatever it was trying to do before and start over again. Moving to the other choices, options, lets us handle several formatting chores, primarily involved with how the output looks when it gets to the page. Clear allows us to reset previously recorded settings. When we're all set, we'll type G for go and get our report. However, let's consider these choices as they apply to our particular model. Range is certainly something we need to specify, so we'll type R to select it. Aha, we're back to something very familiar. A range for the print command is no different than any other range needed by the 123 program, and it's entered in the same way. Let's do it by pointing with the cell pointer. We would like to include our titles and labels in this report, so we'll start with an upper left corner that allows for both. What about A2? Typing a period anchors the range at that position, and we can now point out the lower right corner of our schedule. It looks like N12 will cover everything, so we press return to indicate we've finished. Before we actually print, there's one last thing we have to take care of. The print command has some default settings that we need to change. Let's type an O to select options and take a look at the margin settings by typing M. When we type an L for left, the program shows us the default setting for the left margin. This is the number of spaces the printer will indent everything before printing. As it happens, our model is rather large, so we will need all the room we can get. We'll just change this setting to 1, therefore, and press return. Now we can check the right margin setting by typing M for margin again, then an R. In this case, we'll specify 132 to indicate that we have a wide paper in our printer. Once done, we will quit this submenu and return to the primary print submenu. Well, it looks like we're ready to go, so why don't we do it? Type a G for go, and the printer should start. There, now we're finished. Let's advance the paper and take a look. Wait a moment. We don't want to confuse 1, 2, 3, remember? So let's press P for page once or twice so that we can easily tear off at the perforation. It looks good, ready for distribution. Sometime you may want your report to include special titles, page numbers, or certain other features. These are all possible with the options selection of the primary print submenu. These selections are explained in further detail in your workbook. In this session, we've shown you how to take the model you've been working on and reproduce it on your printer. After you've completed your workbook exercises, the next session will introduce you to the ways to manipulate your screen display. When we discussed printing in the last session, I mentioned that often a model is too large to be seen on the screen all at one time. To get around this potential problem, the 123 program offers us the window and titles commands. We can use these commands to manipulate our screen display so that we can see different portions of our model at the same time. First, let's talk about the window command. If we change starting sales in our income statement to 2,000, we have to race over to column N to see how the change affects our totals. It would be better, I think you'll agree, if we could watch the totals change at the same time as we make changes in the data entry area. Well, as a matter of fact, we can. The 123 program allows us to exchange one large window for two smaller ones, so we can see more than one area of our worksheet at the same time. Let's see how this works. Let's divide our screen vertically between the December figures and our totals for the year, using the window option of the worksheet command. The screen display will be split to the immediate left of our pointer's position. We only need one column in the window on the right to display the totals, so we can start with our pointer in the column N. Now, let's call up the command menu by typing a / and accept the worksheet command. We select the window option by typing W, and again, we have several options to choose from. As you may guess, the horizontal and vertical options split the screen in those directions. We'll find out what sync and unsync mean in a moment. The clear option allows us to cancel or remove a window we have created previously. To divide our screen vertically, we type V for the vertical option, and right away our screen is divided into two separate and distinct displays. Notice something. The pointer has appeared in the left window. Now, how do we get this to the other side? Well, we do this by pressing the special function key F6, which causes the pointer to jump back and forth between the windows. Let's go to the left window and change starting sales to 4,000. With a divided screen, we can immediately see how this change affects our totals. We don't need to scroll back and forth to see what's happening. A real time saver if we were looking at a variety of what-if situations. Now, let's see what the synchronous and unsynchronous options of the window command will do for us. If either one of the windows is scrolled vertically, the other window moves right along with it. This is called synchronous scrolling. The 123 program automatically synchronizes our windows when we split the screen. But what if we don't want them to scroll together? In that case, we can change to unsynchronous scrolling by using the window command again, and choosing instead the unsync option. Now, when we move one of the windows vertically, the other one stays where it is. We can also create horizontal windows, which divide the screen horizontally, and offer the same basic features as vertical windows. Now we know how to split our screen. How do we get back to a single window? To do this, we return to the window command options where we type C for clear. The extra window is removed from our screen immediately. Please turn to the workbook now and complete the exercise on the window command. When you return, we'll continue our discussion of ways to alter the screen display. Let's continue by identifying another potential problem with the screen display. When we scroll the worksheet to the right, the row headings, sales, cost of sales, etc., disappear from view. In this case, it's not a significant problem. With only a few rows, we can probably remember that the first row contains our sales figures, the second, cost of sales, and so on. But what if we were working with a very large worksheet? Or what if someone else was trying to review our worksheet? Not knowing which row is which could pose a problem. This is where the worksheet titles command is very useful. It allows us to keep the headings fixed on the screen as we scroll the worksheet below or beside them. Let's use this command to freeze the headings for our rows. As with the window command, the program will place our titles immediately to the left or above the current pointer location. Here we have placed the pointer in column B. You'll see why we chose this location in a moment. Now we type a / for the command menu and select the worksheet command. We'll choose the option titles by typing the letter T. Now we're given another choice of options, Horizontal will freeze the headings above our pointer, vertical will freeze the headings to the left of the pointer, and the option both sets both horizontal and vertical titles at the pointer location. The clear option removes or cancels all titles. In this case, we would like to freeze the headings to the left of our pointer, so we'll type V for vertical. See what happens when we scroll our worksheet to the right? The headings Sales, Cost of Sales, and Gross Profit remain on our screen, and our rows of numbers are easy to identify. Just for fun, let's set both horizontal and vertical titles. First, we'll put the pointer at cell B7. Then we'll call up the title subcommand, and since the option both is already highlighted, we'll just press return to accept it. Now when we scroll the worksheet vertically, the month names remain. Likewise, as we move horizontally, the row labels can be seen while the numbers move by. This combination of vertical and horizontal titles is very useful if we are reviewing a large model. To cancel the titles, we'll use the titles clear option, like this. As expected, the titles are removed from the worksheet. In this session, we've looked at the window and titles options of the worksheet command, which allowed us to alter how the worksheet was displayed on the screen. Now it's again time for you to turn to the workbook and complete the exercise for this section. In the next session, we'll be looking at some advanced functions of the 1-2-3 program. We've already looked at some of the 1-2-3 program's functions, sum, average, and count. Those were a good introduction and probably the most commonly used. However, as we mentioned before, there are many more functions available to us. In this session, we'd like to take a look at some of the more advanced functions. You may not use these immediately, but it's good to know they exist, so you can use them when you're ready. Before we get into the functions, perhaps I should introduce you to a feature of the 1-2-3 program which provides needed assistance along the way, the online help screens. The help screens are rather like a reference manual. They provide detailed information tailored to any specific situation. These screens can be called up at any time as long as the 1-2-3 system diskette is in drive A. Pressing the help key, F1, causes the worksheet to be temporarily replaced by a screen full of information. There are about 200 help screens. They are all interconnected and cross-referenced, so you can move quickly and easily through the screens to find whatever information you're after. To return to your worksheet, you simply press the escape key. We'll take a closer look at this feature after we find out more about functions. The 1-2-3 program's functions are classified as mathematical, statistical, logical, financial, dates, or special. The mathematical functions include trigonometric and logarithmic operations, as well as absolute value, which ignores the sign of your value, integer, which cuts off any decimal positions, square root, which has its usual meaning, and round, which rounds a value to a specified number of decimal places. Statistical functions include sum, average, and count, which you've already seen, as well as others that allow you to extract the maximum or minimum value in a range or to calculate the standard deviation. Boolean or logical functions are decision-making functions. Let's take a look at an example of how these might be used. Here we have a perpetual inventory model for widgets. Row 2 is set up so that we always know very quickly the number of widgets that need to be ordered to maintain a minimum quantity on hand. Here at C2, we have a logical or decision-making function to determine that number. This is what that formula looks like. Let's take a minute and analyze what it says. Another way of stating the formula would be @ if, left bracket, math expression, comma, true, comma, false, right bracket. The @ indicates this is a function. Remember, all functions start with this symbol. If is the function name. In the brackets are the arguments for the function. An argument is simply information provided to a function that is needed to calculate the result of the function. If requires 3 arguments, which must be separated by commas. The first argument is the mathematical expression to be evaluated as either true or false. The second argument is the value to be used if the expression is true. The third argument is the value to be used if the expression is false. Going back to our function at C2, we can interpret this to read, if G11 is less than 100, then choose the value 100 minus G11. Otherwise, choose the value 0. G11 is our ending inventory amount. If it falls below 100, the number of widgets we must order to maintain a minimum stock of 100 is indicated at cell C2. Now, please turn to the next workbook exercise to try your hand at using this if function. Welcome back. Let's take a look at some more functions. The financial functions are useful for analyzing potential investments. These functions can be used to determine the internal rate of return, net present value, or the payment schedule for an investment. Let's use the payment function to calculate the monthly payment for a loan of $100,000 that is to be paid off over 10 years. First, we need to know what information is necessary to use the payment function. To find this out, let's use the program's online help screens. Remember how we call for help? By pressing the help key. This is the initial help screen. Options that are available to us from this screen and all other help screens are in bold print. Let's look at the help index. We use the arrow keys to move the pointer to this option at the bottom of the screen and press return. At functions is one of the options in the index, so we move the pointer to that option and again press return. On the next screen, we get a brief description of what an at function is and what the different classifications are. Remember, we mentioned that the payment function is a financial function, so we move the pointer to financial and again press return. Now it looks like we're getting closer to the specific information we need. On this screen is a list of the various financial functions, a description of the arguments needed for each of these in brackets, and the result they will yield is to the right. The form for the payment function is at PMT. The arguments required for the payment function are PRN, INT, and term. These abbreviations are deciphered at the bottom of the screen. PRN is principal. INT is the interest rate per payment period, and term is the number of payments. To the far right of the payment function is the word payment. This is what the at payment calculation will yield, the amount of the payment given the principal, interest rate, and term. Now that we know a little bit more about the payment function, let's go back to our worksheet and try to use it. To leave the help screens, we press the escape key and return to the worksheet as we left it. On the worksheet, we already have the assumptions set up. The principal is $100,000. The interest rate per period is 1% on a monthly basis, or 12% for the year divided by 12 months. And the term is 120, 10 years times 12 months per year. All we have to do now is to calculate the monthly payment using the payment function. First, we type the at sign. Then the short form for payment, PMT. And next, our arguments must be enclosed in brackets, so we type a left bracket. The first argument is the principal, so we point to the cell where this has been set up, and then type a comma. The next argument is the interest rate per period. Again, we use the pointer and type a comma. The final argument is the term. Once again, we point to this, and since this is the last of our arguments, we close with our bracket and press return. There you are. The amount of each payment appears on the worksheet. Why don't you try using the payment function now on your own? Turn to the workbook and do the next exercise. Welcome back. If you remember, the payment function you just built is classified as a financial function. There are still more functions to come, so let's take a look at some of them. The date function can be used, among other things, to present a date in a format which can be used for aging. For example, if you want to age accounts receivable. There are also what we call special functions, which really don't fit into any of the other classifications. However, among them is a useful function called the lookup function. This is used to look up values in tables and can operate on either a vertical or a horizontal range. Now, if this doesn't make too much sense to you, we're going to take a look at how the lookup function works. Here we have already set up a marginal tax rate table on this worksheet. In column A, we have listed taxable income. In column B, we have the base tax at each income level, and in column C, we have the tax rate on the excess income. We can find the total tax due for a given taxable income by adding the base tax and the additional tax. Equations for these are set up in columns E through H. We use the lookup function here to find the base tax and the rate for the additional tax. Let's look at the formula for the base tax. We can tell this is a vertical lookup table because of the V after the @ sign. To talk about the arguments, let's refer to them as X, which corresponds to E4, range, which corresponds to the range A3 through C11, and offset, which corresponds to 1. Range defines the parameters of the lookup table. For a vertical lookup, the values in the first column of the lookup table are called the comparison values. In this case, these would be the values in column A. The X argument is called the test value. The program searches down column A until it finds a comparison value larger than the test value. Then it backs up one row. The offset argument determines how many columns to the right of the comparison value to look to find the value to be returned to the lookup function. Let's step through our example to see how the 123 program calculated the lookup function for base tax. E4, our test value, is 26,781. The table range includes the area from cell A3 to cell C11. Searching our comparison values in column A, we find that the first value larger than 26,781 is 28,800. So we back up one row to 23,500 and move to the right one column, our offset argument, for a lookup value of 4,349. In this session, we've looked briefly at some of the 123 program's advanced functions. We just wanted to let you know what's available without getting into too much detail. You'll find a complete listing and detailed descriptions of all functions in your 123 manual. Take some time later on, after you're comfortable with the basics of the program, to explore these on your own. They say a picture's worth 1,000 words, and it's true. Sometimes looking at a report full of rows and columns of numbers can be rather awesome, or perhaps the word is tedious. The 123 program, however, has once again anticipated our needs. The program has the capability to draw graphs based on the data in our worksheets. This visual representation of numeric data is often very effective. It can be used to illustrate trends and relationships difficult to pinpoint by simply looking at a schedule of numbers. To see how it's done, we'll create a very simple graph using the monthly figures from our income statement model. Let's get started. We type a slash, then G for the graph command, and here we have our primary graph menu. Let's see what the type option does. Aha! The 123 program is asking us to choose the type of graph we would like. Why not try a bar graph first? To do this, we press return to record this selection, and this brings back the primary graph menu. What next? Well, we need to define the ranges we would like plotted. Let's assign our sales figures to range A. To do this, we type an A and are asked to enter our first data range. We move the pointer over to January sales, type a period to anchor the range, and then move over until we've included December sales. And then we press return. Now we'll do the same to assign our cost of sales figures to range B and our gross profit to range C. There, that didn't take long, did it? Before we view the result, let's tell the graph feature that we have a color monitor. Choose O for options, C for color, then quit to return to the graph menu. Let's see what we've got now. We'll select V for view. That's quick. The only thing is, which bar is which? Pressing any key takes us back to our menu and redisplays the worksheet. Let's now set up a legend. To do this, we'll use the option selection again, and we'll type O to be presented with another menu. We'll look at some more of these options in a moment, but for now, let's select Legend. Here we have another menu. Okay, first things first, we'll start with A. We're prompted to enter the legend for A range, which should be sales. When we press return, we're once again back at the options menu, but we still have to name our B and C ranges. So we'll select Legend again and type B for the B range. This range is our cost of sales, you'll remember, or COS. Okay, now Legend again. C, we type gross profit, and end with return. We're done. So now we'll quit to go back to the primary graph menu. Let's see what our graph looks like now. Remember, V is for view. Well, that's a bit better, but we really should have a title. So let's press any key to bring us back to the menu and the worksheet display, where we'll try options again, and this time pick the titles option. First and second, we'll put titles in the first and second lines at the top of our graph. X-axis and Y-axis, we'll put titles along the X and Y axes respectively. Let's pick first. We enter the title Income Statement and press Return. Again, we're back in the Options menu. Okay, we'll go back in and set up a second title, Last Calendar Year. Keep in mind that if you make a typing error, you can always back up with the backspace or rub-out key to correct it. Again, we'll quit this menu and see how our graph looks now, pressing V for view. A distinct improvement, but perhaps it would be easier to look at if there were horizontal lines forming a grid. We're getting lots of practice with options. This time we'll pick Grid. Here we're offered the choice of horizontal lines, vertical lines, both, or clearing lines previously set up. Let's press H for horizontal, quit, and view the results. At this point, perhaps we should try another type of graph. Why not a stacked bar graph? To do this, we choose the type, S, for stacked bar, then V for view. Terrific. Now it's your turn. Complete the exercise in your workbook, and when you're ready, we'll look at some more interesting things to do with graphs. Now we're into the swing of things with this graphing business. Let's see what else we can do. What happens if we make changes to the data in our worksheet? How will this affect our graph? Let's find out. Let's change starting sales to 2,500. And just for fun, let's change the cost factor to 85% and see what it does to gross profit. To go back to the graph, we could use the graph view command again, but this takes time. So let's make use of a special function key for graphing, F10. Pressing this key tells the program to switch over and draw the graph, without us having to worry about getting through the menus. Notice our scale has expanded to take in the increased sales, and gross profit has taken quite a beating. Graphs can be printed using the print graph program supplied with the 123 program. Using this program revolves primarily around the kind of printer or special graphics plotter attached to your system. Although we won't be learning how to use this program today, it may be useful to know how to save our graphs in a file to be printed at a later time. Here we are in the primary graph menu. As you can see, one of the options is called Save. When we type S to select this option, we are prompted to enter a graph file name. Let's name this graph Demo and press Return. The disk drive light comes on and we hear whirring noises. When it stops, we're back at the primary graph menu. That's all there is to it. In this session, we've discovered how to create graphs using the graph command. Let's very quickly review the steps involved. First, we chose the command by typing G for graph. Then we assigned our data to range names, A, B, C, and so on. We could have named up to 6 ranges for a single graph. Then we picked a style of graph and saw how easy it was to change this if we wished to. We also saw how easy it was to change data in our worksheet and to see the results in our graph right away. After you've completed the next workbook exercise, we'll go on to discuss another versatile feature of the 123 program, data management. So far, we've explored the powerful calculation and graphing capabilities of the 123 program. We'll now see how we can use this same structure to create and manipulate a database. But what exactly do we mean by database? A database is simply a group of records, a file of information. Let's suppose, for example, that we wanted to keep a list of employees, including certain specific information like name, level, department, and location. To do this, we would make up a record for each employee, with a specific area to put each type of information in, rather like a form. Each of these areas in data management terminology is called a field. Therefore, a group of fields makes up a record, and a group of records constitutes a database. The 123 program recognizes a row of entries as one record, and the individual cells by column as fields. Each column may contain only one specific type of information for all records. To show you what we mean, we've loaded a database or file representing an employee list. You'll notice that in row 2 we have entered labels which serve to indicate what type of information each column contains: name, level, department, and location. These are called field names. Information has been entered under each of these headings relating to the employee named on the left. For example, the department field for Williamson's record contains the number 3. The level field for Fredrickson's record contains PT, short for partner. In this session, we are going to show you how to use the 123 commands to manipulate such records. First, it's Seems we forgot to assign employee numbers to these individuals, and this means adding a new field per record or another column to our list. How do we do this? Simple. You've already learned how to use the worksheet insert command. Let's put the column at the far left. So we place our pointer in column A, type slash, W for worksheet, I for insert, C for column, and then press return. There it is. Now we need a field name to indicate the type of information to be kept in this column. We'll call it the employee number field. Let's assign some employee numbers. We'll make them sequential, starting with the number 1. Rather than type them individually, we'll make use of the data fill command. It was designed especially to take care of such tedious chores. We type slash and D for data, and are then presented with a new menu of options. We'll choose fill by typing an F. The program asks us to define a fill range. This means simply that we must tell the 123 program where we would like our numbers to appear. We can indicate this, as you have probably guessed, by pointing to the first and last cells in our range, A4 through A33. Next, we are asked for a start number, and the 123 program suggests 0. In this particular case, we would rather start at 1, so we simply type the number 1 and press return. Now we are prompted to enter a step number. That is, how much do we want the value to increase in each of our successive cells? The suggestion 1 is correct here, so we simply press return. Finally, we are asked for a stop number. When do we want the 123 program to stop inputting numbers? The program will automatically stop either when it has filled up our range or when it reaches the stop number indicated here. If our numbers were likely to run higher than 2046, for example, if we stepped each number by 100, we would have to change the stop number. It's not necessary in this case, so we press return, and in a flash, our employees are assigned numbers. We'll pause here so you can experiment with the data fill command. By the way, it isn't limited to just columns. It works just as well for any range of cells. Now that you've had your first crack at a database and your first taste of data commands, you're probably anxious to learn more. By the way, don't forget to try the data fill command when developing regular worksheets too. Now we'll move on to take a look at the data sort command. When we choose sort from the data options, we are presented with a new menu. To perform sort, we'll first have to tell the 123 program which range of cells we would like to sort. To do this, we'll use the data range option. Remember ranges? We've used them many times before. First, the program asks us to specify the range of cells containing the data we would like to sort. We don't want to sort the row that contains our field names, so we won't include this in our data range. But here's an important fact to remember. In our range, we must include all the fields or columns composing our records. This is critical to ensure that all fields for a particular record stay together. If even one field or column is accidentally left out of a data range, it won't be reordered with the rest of its related information. In our example, our data range includes the area from A4 down to and including E33, which, as usual, we can point out with our cell pointer. When we press return, we come back to the sort submenu. Now that we've told the 123 program what we would like to sort, we have to tell it how we want the information sorted. The program needs to know which field is to be the basis for the new order. The field we choose is called the key. Let's sort these records by department number. This means that column D, the department field, will be the primary key for our new order. To set this up, we type P for primary key, put the pointer anywhere in column D, and press return. Now the program needs to know if we want these records sorted in ascending or descending order. It suggests an A for ascending, which means that it would start with the lowest number first. Once again, pressing return brings us back to the sort submenu. It seems likely that we will have more than one employee in each department. Therefore, perhaps it would be a good idea to have them organized alphabetically within their department. This is easy for us. We simply set up the name field as a secondary key by typing S, moving the pointer to column B and pressing return. Again, do we want them in ascending or descending order? Labels sorted in ascending order will start with the A's and work through the alphabet, which is just what we want. So we press return again. Let's see what happens when we press G for go. In no time, our employee list has been reorganized by name within department. In this session, we've discussed the formats used by the 123 program to create and maintain a list of records, a database. We found out how to handle our sequential numbering and use the data sort command to reorganize our records. In the workbook exercises that follow, you'll explore these new possibilities, and in our next session, we'll discuss some more of the 123 program's data management capabilities. In our last session, you were introduced to the data management capabilities of the 123 program. And now that you know how to manipulate information en masse, let's find out how the 123 program allows us to focus on individual records and allows us to search and retrieve specific information. Let's look at the primary data command menu. One of the options here is query. We'll use this option to ask questions about the contents of our database and see how quickly the program can provide the answers. When we type a Q, a new menu of options is displayed. We'll use some of these to query our database. Let's try the input option. Remember how we specified the data range in our sort command. Here we are asked to do something similar. We must indicate the range of cells to be searched for information. There is, however, an important difference. When we defined a data range to sort, we didn't include the field names because we didn't want these sorted in amongst our records. In this case, however, the input range must include the field names because the 123 program will need to match these names as part of the criteria of a search. This will become evident as we progress. Our range will therefore include the entire body and headings of the database. Starting at A2, we'll use our cell pointer to point out the range down to and including E33. Pressing return will bring us back to the query menu. Now that we've defined a range for the program to search, we need to set up a criterion or basis for the search. The program needs to know two things: which particular column it should search, and once there, what it should look for. This is the reason we had to include our column names in the input range. The 123 program must match first the column names before it can look for the data stored in those columns. Suppose we wanted to find all the employees at the level M. How do we go about telling the 123 program what to look for? We need to pass two parameters to the program: the column name and what to find in this column. Let's set up an area a couple of rows beneath the database where we can put this information. We type level, which is the name of the column we would like to search, and underneath this M, the specific contents we're looking for. We've positioned the contents under the field name because that's how the 123 program interprets our instructions. Under level, look for M. Now we must tell the program where we placed these two instructions, or in other words, we must set up the criterion range. So we press /D for data, Q for query, and then C for criterion. When prompted to name a range, we can point to the cell containing the word level, type a period to anchor the range, and move down to include the M. When we press return, we're brought back to the query menu. You can see that one of our options is find. Let's try it. Almost immediately, the program locates the first record matching our criteria. To see the next record containing an M in the level field, we press our down arrow. If we want to go back and look at the previous record again, we simply press the up arrow. In this way, we can browse through all records matching the criteria we have defined for the search. But supposing we wanted to know the employees at level M only on the 21st floor, how would we do this? Let's put this additional information with our other criteria. Beside our other field name level, we type floor, and remember the relationship? We want to tell the 123 program, under floor, look for 21. So in the cell below floor, we type the number 21. There's something else we must remember to do. The entries we just made are outside the criterion range we specified earlier. So we'll need to change the range. To do this, we type /D Q C to point out the new expanded range. Now we're ready. Okay, 1, 2, 3, find those records. Here's our first matching record. Terrific. As you can see, the 123 program can handle multiple criteria for a search. In this case, it looked for all records with an M in the level field and 21 in the floor field. Take some time now to complete the next workbook exercise and try some searches on your own. Now that you have a feel for defining search criteria, there are some interesting features you should know about that can be real time savers. Wildcards and the special function key for query, F7. First, let's talk about the special function key. Setting up a search takes some initial effort. You have to define your input range, set out the criteria, and then define your criterion range. What would happen if we wanted to change floor 21 to, say, 32 in the middle of our search? Would we have to stop to edit the entry? Well, as it happens, no, we wouldn't. The 123 program remembers all the specifications we've already entered, and all we have to do is to change 21 to 32 and press F7, which lets us jump right back into our search. Now, what about wildcards? No, the 123 program may do a lot, but it doesn't play poker. Actually, wildcards are characters we can use when defining our criteria, which allow a more flexible search. Let me explain. For example, the asterisk, which is a wildcard character, will cause a match on anything that follows it. For example, SMITH asterisk would find the records for Smith, Smithson, or Smith Corona, but not for Smythe, SMYTH. You'll be given some practice with wildcards in your next workbook exercise. For now, let's move on to see how we can use the 123 program to do more than just find records, to list them too. In our previous example, the program highlighted each record in the database, but it could just as easily have listed them as a group in an area outside the database if we had told it to do so. In our previous example, we were searching for level M employees on floor 21. Let's list these right below the criterion range. Remember how we set out the criteria for a search? Well, here we do something similar. We'll type name next to that level, and one cell over, floor. Notice we've been careful to spell these labels exactly as they appear in our database field names. Okay, we've set up the field names of the information we would like, but we still haven't informed 123 that it should consider these entries to be our output range. We'll do this using the output option from the query submenu. Here, all we need to indicate are the cells containing the output field names. So we type slash, data, query, and output. We then point to our output titles. Okay, we're ready to go. This time, let's pick extract from the query menu. In an instant, the 123 program has copied the required information from all records that match our criteria into our new database. Once again, when we quit the data command, we can reactivate it simply by pressing F7. For example, to find partners on floor 21, we type PT for partner, return, and then F7. Voila, a new list is displayed. As you've seen, the 123 program provides considerable power and flexibility in creating and manipulating a database. In your next workbook exercise, you'll have an opportunity to explore the database features you've just seen. So far, we've been working with a relatively simple set of assumptions. Plus, you really haven't had to worry about what it means if somebody else were to use your model. Somebody who may not be as familiar as you are with the 123 program. What I'd like to discuss now are a couple of ways to protect your model from accidental destruction. Do you recall one of the benefits of a data entry area? By keeping our pointer away from the body of our model, we were able to reduce the risk of accidentally typing over one of our formulas. The 123 program has a feature which builds on this concept and virtually eliminates the accidental destruction of formulas. This is done with the protection feature. Let's see how this works with our model. To activate protection, we choose the worksheet command, /W, then global, by pressing return, P for protection, and E for enable. No apparent difference. But what happens if we try to type over a cell containing a formula? As soon as we press return, the message, protected cell, appears at the bottom of the screen, and error appears in the mode indicator. Think about it. This means our model is protected. Formulas cannot be accidentally overwritten. We press return once more to acknowledge the error, and let's see how the model reacts to changes in the data entry area. Uh-oh, we still have an error. You see, the 123 program protects the entire worksheet when protection is enabled, except for cells which are specifically labeled as unprotected. Let's see if we can do this after pressing return to acknowledge the error. /range, unprotect, then point out the range and return. Look, even a different color. We can change any of the unprotected values, but are still restricted anywhere else on the screen. The combination of different colors and error messages combine well to restrict input to the data entry area. Even though the 123 program gives us ways to prevent accidental destruction, we can never be 100% safe. That's why there's no substitute for backup copies when dealing with these models. We have seen some of the file handling options available to us from within the worksheet portion of 123. Options such as save and retrieve allowed us access to the diskette. There are even more powerful commands available as part of the Lotus access system. These commands become available only if we have quit the worksheet, so be sure all important worksheets have been saved before attempting to use these commands. Let's take a look at some of the access system file handling features. Within the file manager, we are prompted to enter our source disk, meaning the drive which contains our data files. Ours is in B. The important option here is copy, which you will use to back up copies of individual files. To produce copies of an entire diskette, you will use the disk copy portion of the disk manager. Let me mention one last technique that may help you in collecting data from files that other people prepare for you. This feature is part of the regular file command in 123. It's called the combine option. This option, in its simplest yet most powerful mode, allows us to combine or add whole files together. With this feature, we can combine many divisions into one consolidated worksheet without having to re-enter data over and over again. These protection tips are important. If you need to collect data from several remote sites, consider preparing a model with a data entry area, protecting all the cells in the model except those where data is entered, making a backup of your master diskette using disk copy in the disk manager feature, making copies of your model for distribution using copy in the file manager. When the disks are received back from field locations, using combine to consolidate all files. Why don't you turn to your workbook now to study some of these features? In this final session, we'll discuss some of the design and planning hints involved in developing microcomputer applications. As you become a more sophisticated spreadsheet user, you'll probably develop increasingly complex models, and you'll come to rely on the results generated by those models. If you're using the 123 program in a business environment, it's also likely you'll either ask someone else to take on the responsibility for inputting your data, or you may be asked to assist in the development or review of someone else's model. To discuss the problems that may arise and to give you some guidelines on how to control and review the use of spreadsheet models, I've invited my colleague John Martin to join us. John has been developing spreadsheet applications now for many years, or at least 3 or 4, and has considerable experience in teaching the application of spreadsheets. John, perhaps you'd like to share with us some of the common problems encountered.
I think, Andrew, that instead of listing out a whole series of do's and don'ts, I can simply take you through the steps I followed just recently. I was asked to help someone who knew how to use 123, but not really how to build a model.
Mm-hmm. I think that would be very helpful, John. What was the first step?
Well, as funny as it sounds, the first thing we did was try to talk ourselves right out of using 123.
John, I've just finished completing a program on teaching people how to use 123. Maybe you should explain that a little further.
Well, it's maybe not as strange as it sounds. You have to remember, it doesn't make sense to put everything you do on a microcomputer. For example, a schedule that takes only 15 minutes at the end of each month probably isn't a good candidate for an electronic spreadsheet. In our case, after we thought about it for a while, it made sense to go ahead and spend the time to use 123.
Mm-hmm. Well, I'm relieved. And if I can wrap a phrase around what you've just told me,
Mm-hmm.
it would be this, that you spend some time at the very outset doing a small cost-benefit analysis.
Exactly. We sat down and amongst ourselves tried to decide whether it made sense or not to go ahead with 123.
What was the next step? Did you just sit down at the micro?
No. Before we sat down, we had to make sure we knew what we wanted 123 to do for us. Once we knew that, we could then determine what we needed as input for our data entry area. In the income statement you used during this course, what needed to go into the model and what came out was a given. And as soon as you knew that, you could create the outline. And that's the same process I used. But we had to determine what the assumptions were going to be before we sat down.
So you did a preliminary, a skeleton design.
Mm-hmm.
I think you're saying that that skeleton design is not just a useful teaching aid, it's also a practical tool as well.
Definitely. As a matter of fact, that's exactly what we did. We sat down, and with the use of the 123 commands such as move, insert, delete, and copy, we got the outline looking the way we wanted it. Remember, the outline is nothing more than titles. We don't have any formulas in the model at this point, but we do have the ability to use the outline to visualize what the formulas should be.
Mm-hmm. So, what did you do next? Did you create the formulas using the pointer?
Well, we could have, But this model was particularly complex. It was a cash flow model, and we wanted the formulas reviewed and approved by the department supervisor. What we did was to print out just the outline and then write the formulas in for the first month. We didn't use cell references, we used English. If I had to compare it to the income statement model you used, we had a piece of paper with just the data entry area, month, and row headings. When we wrote the formula for cost of sales, for example, we had, in English, current sales times cost factor. This way the reviewer knew exactly what the formula would be. And in our case, our reviewer didn't know 1, 2, 3.
Mm-hmm. So you got the supervisor to review the design of the model.
Mm-hmm.
I'm just curious, why only 1 month?
Well, we didn't want to make the job any more tedious than it had to be. And since we were intending on using the copy command to create the formulas for the rest of the year, we indicated that on the outline with ditto marks.
Mm-hmm. It's one of my experiences that if errors are going to creep into a model, they do so at one of 2 points. Either in the actual design before the thing is created
Mm-hmm.
on the micro, or at the time the formulas are programmed.
Mm-hmm.
What sort of procedures do you take to ensure that errors made are either prevented or detected?
Well, that's a good point, because having somebody review the formulas isn't going to catch all of those errors. What we did was, while the model was being reviewed, we gathered some data processed by the old manual procedures, where we knew what the result was going to be. We then fed this data into the model to test it, to see that it equaled the old manual results.
Mm-hmm. So you used data that for which you knew the results. I mean,
Mm-hmm.
you could anticipate what the results would be.
Exactly.
What happens if you don't have old data to use?
Well, then I think you should create some, because it's extremely important to test the model. You should be able to input some relatively simple numbers and be able to predict the results. If you recall, the income statement you were using started with an assumption that sales for January were $1,000.
Mm-hmm.
I assume you did this because it was easy to predict what cost of sales and gross profit should be with a nice round number.
Well, everything you've described so far, it sounds as if you have a working model. Is it now time to go?
Working model, yes. Ready to go, not quite. We didn't go live right away. We first saved a copy of the model on a backup diskette and printed a copy of the model with the test data. We put the printout in a folder with the original outline and all of the handwritten formulas. This folder then became our documentation file. And while we were at it, and since it was still fresh in our minds, we also wrote up a brief description of what the model was supposed to do and where to gather the input data. This information then became part of the file.
Forgive me for saying so, but that sounds like an awful lot of work. Is that necessary in every case?
No, of course not. But if you recall, I mentioned that this was a relatively complex model. And as a matter of fact, the model produces some information that impacts 2 or 3 key decisions. That's why we went to the trouble we did.
So you're saying to me that the decision to document a model is rather subjective,
Mm-hmm.
and really depends on 2 things: the complexity of the model and how critical the results are.
I think you're right. Let me give you another example. I recently worked on a model that evaluated the aging of accounts receivable. And the results of that model impacted the decision to change the reserve for bad debts. That particular model had a file containing all of the elements of documentation we've talked about today, including the review and approval of the engagement partner. On the other hand, I also use 1, 2, 3 to accumulate my own personal expenses. And because that doesn't affect anybody but myself, I didn't go through the effort to formalize the documentation.
Mm-hmm.
But it helped. I still used the same procedures in an informal manner that we've talked about.
John, thank you very much for sharing your experiences with us. One final point. I know we've discussed it before, but I think it's important enough to repeat. To protect yourself against the loss of time and effort, save your worksheet periodically to diskette. Unfortunately, power failures do occur. People do trip over microcomputer cords and so on. So every time you've been working on the computer for half an hour or so, save your worksheet from memory to diskette. Also, keep a backup diskette of all key models you've developed and put it somewhere safe. Keep up-to-date hard copy documentation of your models also, just in case your backup diskette is destroyed. To summarize, let's face it, errors are likely to occur either because erroneous data is entered unintentionally or because the model is misunderstood by someone. Fortunately, there are steps we can take to minimize these occurrences, and let me just run through these. Careful planning, a sound worksheet design, good thorough documentation, and knowledgeable review. 123's very flexibility and power indirectly creates some risks. In this final video segment, we've talked about a few of the broader issues of review and control. Take some time later on to review these techniques at your leisure in the control implications section of your workbook. Well, now it's time for you to put the 123 program to work. If you have any problems, you can always refer back to the reference section in your workbook. And let me say in closing, good luck.